Hey there, what is going on? I am back with another problem. This problem is called all elements in two binary search trees. So you will be given the root of two binary search trees. You need to merge them and give a sorted list. So for an example, this tree contains 214 and this 103. So the output in sorted order is all the values in increasing order. So let's quickly dive into the problem and try to solve this. Let's think how we can solve this problem. The first thing we can think of is in-order traversal. In in-order traversal, the left subtree is visited first and the root is then visited and then the right subtree, and this is recursively true for all the subtrees. So if we do that, we can obtain a sorted list in ascending order. Why we can obtain a sorted list in ascending order? Because all the values in the left subtree is less than the root and all the values at the right subtree is greater than the root, and we are doing this in recursive manner. So in this way we can easily obtain the sorted list. So my idea to solve this problem is similar. I will be doing in order traversal for both these trees, and I will use an additional data structure which is mean heap to store all the nodes once I am doing in order traversal, and I am gonna add the root once the left subtree is visited. So then what I will do is I will keep extracting the mean elements and add that to the result list. Okay, so let's try to solve this problem. I need first is a priority queue which will be of type integer. Let's call it PQ, and a list for storing the result which will be of type integer. Let's call it result. It's up to you. I would like to create an array list. Now let's create the function for in order traversal. I'm gonna be using the recursive implementation. So the first thing it needs to take is a tree node. Let's call it root, and priority queue of type integer. Okay, the base condition for this is if we occur some value of root which is null, then we simply return. Now in order traversal we first visit the left subtree, so let's just do that. Root dot left and priority queue, then we visit the right subtree at last before visiting the root of that subtree. So here in this case what we should do, so in this case we used to print that value in case of in order traversal, but now we are interested to add this value in the priority queue. Let's call the add method and add this value which will be root dot val. Alright, so our in order traversal is done. I forgot to give the return type. Okay, now once the in order traversal is returned, let's just call this in order traversal method with root 1 and pq, and the same thing for the second tree also. Now once this has been done, values will be added to the priority queue. What we need to do is simply get all those values from the priority queue. So what I will be checking is not pq dot is empty. If the priority queue is not empty, then I would like to add all the values to the result by getting the front element or the root of this mean heap, so which will be in this case pole. Alright, so once we do that, all the values will be added in a sorted order to the result list. So I can simply return the result. Let's run this code. Okay, I'm gonna submit this code. Okay, it's accepted. Now if you want to make this implementation without using a recursion, then we can simply use stack to do that. Let's just do that here. I'm gonna get rid of this. So what we need is a stack of type tree node. Let's call it stack. Now let's take another pointer, which is, let's call it as current, and which initially is pointing to the root node. I'm gonna get rid of all of this stuff. All right. So what we need to check is if current is not equals to null, or the stack size, let's call it stack not stack dot is empty. So if that's the case, we have got a node which is stored in the current. So we need to go deeper in the left subtree. So let's just do that inside another while loop. So what I need to check is current is not equals to null. So once we are doing that, we should keep adding that to the stack. So this is how recursion works. Recursion uses stack data structure. So and then current will be further enhanced to its left subtree. So once it's been done, we have achieved, we have reached some point that which doesn't have any left subtree. So for that case, current needs to be popped out from the stack so that we can get the value and add that to the stack, add that to the result list or the priority queue in this case, because here I'm just adding the values to the priority queue for after doing the Inorder traversal. So let's just pop the value from the stack dot pop, and we should add the value of the current node to the priority queue. Once we are done, we can simply move next. This root is visited, also the left subtree is visited, so we should enhance this. We should go towards the right subtree. So current will be current dot right. All right, let's try to run this code, and again I'm gonna submit. Yeah, that works. Our iterative approach also works. So that was it for this video. If you like this video, please like, comment, share and subscribe. Thank you very much.